Our senior design group has been working on the self-sustaining water filtration system. Our group is composed of Caleb Nelson, Connor Dills, Ella Murray, and Tucker Schrapp, with Dr. Ali Amiri as our mentor and the NDSU Mechanical Engineering Department as our sponsor. Our requirements were to develop a water filtration system that was able to be self-sustaining, portable, and that can filter any body of water at a filtration speed of 1 gallon per minute. To complete this project, 4 major stages occurred. Our conceptual design stage produced our final concept, which we had drawn out with the configuration of all the components in our filtration system. We used these concepts to design a 3-dimensional model of what our system will look like. After ordering all the necessary parts, we began constructing the system. There were a few minor modifications we made to our design through the construction process, which brings us to the final stage of our design, which we have modeled as well.
When our parts began arriving, we made sure to test each component so we knew that all pieces worked as expected. This included all our major filters, electrical components, and the pump. We also ensured that our solar panel fit on the tote when we were using it. Once all pieces were verified to be working, we started to configure our system. This was done by using our 3D model as a guide and making sure we have the correct fittings so that all components will fit in the tote. We used a mix of 1/2 inch to 3/4 inch PEX tubing to connect all of our filtration pieces. We used a PEX tubing cutter to cut the tube into the correct size pieces and a special PEX crimper to crimp the pieces onto the fittings.
After everything was connected, we put our system to the test and ran water through it. The biggest challenge with this step was that our connection points were not as secure as we wanted them to be. This caused leaks in the system and the flow rate to drop as we lost pressure at those leak points. After adjusting the connections by adding more plumber's tape and securing the crimp rings, we ran the system through again and it was much more effective, with no leaks and a higher output flow rate. We used 3D printing to create some additional parts we needed and began attaching everything to the tote and connecting the electrical. With these parts completed, we are left with a finished product.
To overview our system, water is pulled in by the pump through the inlet. The water first goes through a sediment filter to remove any larger debris. It then either goes through the pump or a bypass loop if the inlet is connected to a pressurized hose. After this, the water is sent through 2 parallel carbon filters and down to an arsenic filter. After these filters have removed the chemicals necessary, the water passes through a UV light filter to eliminate any bacteria before exiting through the outlet. All components are attached to an aluminum frame for easy access. On the tote, there is a user interface that shows the battery percentage as well as switches for the pump, UV light, and solar panel. We also have the option to power the battery via hand crank or plugging into a wall outlet. These components are stored in our removable tray inside the tote, along with extra filters and any other extra parts needed.